Hello guys, welcome to our class for today. I hope you are doing fine and you are good in wherever you are, and also hope that our physics lectures, they are impacting on you positively. So if they are impacting on you positively, please help us to share these videos on your various social media platforms. Invite your friends to come and enjoy what you are enjoying, and also tell them to subscribe to the channel so that when we upload a new video, YouTube will notify you. This is My Science Tutors Online, and I remain notable Michael. I am your online tutor, and if you have any challenge, please you can reach us via the WhatsApp number that is showing right on your screen. Is that okay? So please get your writing materials ready. Get your biros, get your calculators, your writing pads, so that we can go to our class for today. In our class for today, we'll be looking at electric potential and electric potential difference. Electric potential and electric potential difference. So we'll be deriving the formula for electric potential and electric potential difference. Then we'll see the relationship between electric field intensity and electric potential difference. Then we will now solve some problems relating to this equation that we have derived. Alright, so hope that you are ready. Let's go straight to our class for today. Electric potential. Electric potential at a point is represented by V, and it is defined as the work done in bringing a unit positive charge from infinity to that point against the electrical force of the field. Is that okay? So electric potential has to do with work done. Yes, because it has to do with energy. You know, when we talk about potential energy, we're talking about the energy that you possess due to your position. So electric potential has to do with energy, so it has to do with work done. And this one, we have said that it is the work done in bringing a unit positive charge from infinity to that point against the electrical force of the field. Okay, so what that simply means is that electric potential work done is equals to charge times voltage, and which is equals to Q times V. And V is equals to work done all over charge, and that is Joule per Coulomb. Okay, so work done is equals to Q times V, which is Coulomb times volts, and V is equals to work done all over charge, and this is now we know that work done is equals to what? Force times distance. So if we put it into this particular equation, well, that will now be force times distance all over charge. Now remember that force, electrical force, is given to us as the product of the charges all over their distance squared multiplied by the constant of proportionality K, which is given by 1 over 4 pi epsilon 0. Okay, so this is the force. So work done is equal to force times distance. Then all this one divide by for V, which is electric potential. V will now be equals to this force multiplied by R. You know, even if you just multiply this out, you're going to have this K all over R. So this is what you have. Okay, so you have that this will now be K Q all over R, everything divided by Q. So this is the work done part of it, and then this is the Q on this particular equation. Okay, so this is your, that is your V. This is your now your V. So you know that this equation you can also write it as K Q K all over R times 1 all over Q. So this will cancel this, so that you will have now that K Q all over R. Okay, so this gives you the electric potential at a point due to a charge Q at a distance r from the charge. Remember that your K is equals to this. Okay, remember that K is equals to 1 all over 4 pi epsilon 0. Don't forget, I'm only putting that K there, but remember that K is equals to this. Okay, so if you remember that, you'll see that this equation is exactly like this. Alright, so this equation gives you the equation for the electric potential at a point. Electric potential at a point due to a point charge that's at a distance from the charge. So that is the equation for the electric potential. Okay. So please don't also forget these simple equations. I'll put them in a summary slide so that we can see them readily, because we'll make use of them when we want to solve some problems. Alright, so this is electric potential. What about electric potential difference? Alright, so let's consider 2 points A and B in an electric field. Okay, so if more work is done in moving a unit positive charge Q from infinity to A more than B, we will say that A is at a higher potential to that of B. So if A is at a higher potential to that of B, then it means that there's a potential difference between A and B. So that is why the potential difference between 2 points A and B is defined as the work done in moving a unit positive charge from A to B. Okay, the work done in moving a unit positive charge from A to B is equals to the potential difference. Now remember that we just said that work done is equals to what? Potential difference times charge, that is Q times V. So to move a charge from A to B, it will mean the potential difference between A and B multiplied by the charge. Okay, so and that gives you this particular equation that is here. This gives you the equation that is here. Now we can also find a relationship between the potential difference and electric field intensity. Okay, so remember that we said that work done is equals to what? Force times distance, which is equals to F times R. And electric field intensity is equals to force per charge, right? It's force per unit charge, and that force equals to the charge times electric field intensity. Okay, force is equals to what? Force equals to what? Charge times electric field intensity. Okay, so if we have that, we can now say that work done is equals to force times distance, which is charge times electric field intensity times R. So this is now your equation 2, and this is your equation 1. So if we equate equation 1 to equation 2, we are going to have that charge times electric field intensity, which is this, is equals to Q times V. So these two, they are work done. So this is work done, and this also work done. So this will cancel out, So you have that electric field intensity, that distance, is equals to potential difference. So from this now we can get that electric field intensity equals to potential difference all over the distance of the charge, and the unit for this one is volts per meters. Volt per meter. So this is relationship between the electric field potential and electric field intensity, and the potential difference. Alright, so this is our relationship, and in the next slide I'm going to display the summary of all these equations that we just discussed. So this is a summary of all the equations we just discussed. Potential difference equals to work done all over charge, and which is equals to this, and we said that work done is equals to Q times V. Then the relationship between potential difference and electric field intensity is equals to this. V is equals to electric field intensity times R, or E is equals to V all over R. Then we say electric field intensity equals to force all over charge, and force equals to charge times electric field intensity. So these are the equations that we have enumerated so far. Okay, so with these equations in mind, we are going to solve some problems now. So this question says that two parallel plates are charged to a voltage of 40 volts. If they are separated by a distance of 10.0 centimeters, calculate the electric field intensity between them. So in this particular question, you are giving V to be equal to 40 volts. You are giving distance to be equal to 10 centimeters, and which is equals to 0.1 meters. Sorry, that is 0.1 meters. 0.1 meters, and you are asked to find what? E. Okay, you are asked to find E. So from our discussion so far, we had that E is equals to what? E is equals to V potential all over R. So just substitute those equations. So you have 40 all over 0.1. Okay, so E will be equals to 400 volts per meters. 400 volt per meters. I think that is quite simple, right? So these topics, they look somehow, but they are not difficult to solve problems on. So that is for this particular question. I hope this one is understood. This is a JAM question. Okay, so this is another question for us to consider. Say that calculate the potential at a point 40 centimeter from a charge of 3 times 10 power minus 6 coulomb. Take proportionality of constant of proportionality to be 9.0 times 10 power 918 meters squared per coulomb squared. Okay, so in this particular question, you are given distance to be 40 centimeters, which is equal to 0.4 meters. You are giving the charge to be 3.3 times 10 to the power minus 6 coulomb, and you have your constant of proportionality. Okay, you have your constant of proportionality. So they say calculate the potential difference. Now from our derivation, we have that potential difference equals to KQ all over R. So just substitute into this equation. Your K has been given to you to be 9.0 times 10 to the power 9 your Q is given to you to be 3 times 10 raised to power minus 6. Divide everything by 0.4. Is that not? So your V will be equals to what? We'll solve that out. Your V will be equals to 6.7, 6.75 times 10 raised to power 4 raised to power 4 volts. Okay, so if once you know how to apply the equation, I don't think you have much problem. Is that okay? Just know how to apply the equations. You can solve any problem that you wish to solve. All right. This is another question. This one says that two parallel plates at a distance of 8.0 times 10 power minus 3 meters apart are maintained at a potential difference of 600 volts with the negative plate earthed. What is the electric field intensity? All these are mini grammar. What you should understand is that in this particular question, you are giving V to be 600 volts. You are giving R to be 8.0 times 10 raised to power minus 3 meters. And you are asked to find E. E is unknown. So from E is equals to V over R. You just substitute your values into this equation. So okay, so you have 600 divided by 8.0 times 10 raised to power minus 3. Okay, so by the time you work this out, you have that E is equals to E will be equals to 75,000 volts per meters. So forget the mini grammar, just understand what the question is saying, and then you can be able to solve and work your way through. Okay, I hope this one is also easy and you understood it too. So guys, this is your test your understanding page. Is also these questions are just like what I've done, so please try your hands on them. If to charge please are maintained at a PD of this, what is the work done in taking a charge of 600 microcoulomb across? If you remember the microcoulomb, you have to convert it to coulomb. Okay, you have to convert your microcoulomb to coulomb by multiplying it by 10 raised to the power minus 6. So if I have not told you that before, 1 coulomb is equals to 1 microcoulomb is equals to 10 raised to the power minus 6. 1 microcoulomb is equals to 10 raised to the power minus 6. So you have to multiply that by 10 raised to the power minus 6 in order for you to convert it to a coulomb. Is that okay? So once you have done that, you can now find the work done. You know that work done is equals to what? Potential difference times charge. So then for the second one too, a point charge of magnitude, but this is smooth rate distance of this against a uniform electric field intensity of this. Calculate the work done on the charge. Simple too. So guys, please, this is where we are ending our class for today. Try and answer these questions, and if you have any problem, you can always contact us. Okay, but before I leave, please, if you have not subscribed to the channel, subscribe, click on the notification bell so that YouTube will always notify you when we upload a new video. Give us a like, give us a thumbs up, share our videos with your friends on social media and different platforms. Okay, if you have any issues, reach us through the WhatsApp number that is showing right on your screen. Okay, so I remain Otobo Michael. Thank you so much for your time, and thank you for being with us so far. We appreciate you, and we hope that you are understanding and you are enjoying what we are doing. Thank you, and we hope to see you in our next class.